Hi, my name is Afshari, and I'm the inventor of Optoform system. And I've been doing that for quite a while. If you're not familiar with Optoform, I was inspired by the original microbench. This is German-made by Spindler and Hoyer. They were producing these from 1970s, late 1970s. And then I came across with it, and I fell in love with it immediately. I thought, wow, this is the system that I've been looking for all my life. Until I realized how much they cost. The two kits I bought at a camera show for $180 were worth $10,000. So I slowly thought that, wow, what a nice concept. Unfortunately, not everybody could use it. So I came up with an original idea. I called it Optoform. It's round, it's easier to machine. If you look at the cost of producing these, it's easy to come up with how much this would cost to produce. These are made by $250,000 machines. They're live tooling. They have 2 spindle machines. So basically, the manufacturing time to produce these is around 3 to 5 minutes. And you can easily divide by an hour to calculate your shop time, and it's like about $85 an hour, and you can see how much it would cost to produce one of these. Of course, with the CNC machine like that, it's much more. It's maybe twice that much. In any case, with the new Optoform, invented 25 years ago, I was able to reduce that cost, and I had a whole system designed, and we were the first one to integrate linear bearings into Optoform. We didn't know marketing really that much. We were just from trade show to trade show and some small advertising. We were able to sell it, and it was successful not because of, like I said, we didn't have advertising money. It was successful because it was a good product. And the success of Optoform really relied on that until we ended up giving it to Edmund Optics to sell it, to push it. And unfortunately, they took some of our, when was the last time you saw something like this at Edmund Optics booth? They basically only pushed what everybody else carried, and they just wanted to compete with them. And they didn't realize what the importance of this whole setting is, to be able to manipulate and make the whole structure for a microscope, a telescope, an interferometer. And in my classical Optoform, you can go to optoform.com and download this catalog and see what kind of possibilities there are with the Optoform. We covered a huge line of applications, range of applications. In any case, this is the background for where we come from, what our passion is. And I realized I cannot really influence the optical industry with just one invention. So I came up with a new idea. And I think I went back to the square shape, the same size as the original microbench. And I think I have basically connected with the original designer. Design goes through hearts and hearts to come up with with what the original intention was. What I did here was I brought it, basically I thought that I've seen extrusion rods, like say 2020 is a good example. A lot of construction in photonics are done with 22. Basically, they build the whole chassis for different. I'm trying to look for another rod here. Here, I'm going to put 4 rods here to show you. Extrusion, you cannot do precision holes, but you can. If I bring the bores to the side, to the corners, I could. So this is basically the idea. If I have a profile that I could extrude and cut to pieces to come up with this, then I can achieve a lot of, there's a lot of advantages. This first is cost. We can bring down the cost below $10 on these. My goal really is to make it like $2.50, $1.50, very, very inexpensive. The second thing you achieve is you have, when you mount these, here is a lamp housing constructed with the new Optoform. You will have more space between the rods. Let me disassemble this for you to show you what we have done here. Okay, see these mounts on any side, because these rods have a threaded pattern, hole pattern, that you could basically mount on the rods, you see, along the rods, and all kinds of orientations here. Like I said, you're able to insert larger optics between the rods. With the original microbench system, I don't need to show it, you cannot really even insert a 25 millimeter, but in here, mounted optics. But in here you can put all kinds of filter wheels without any impediments, any obstruction. So, what's the second advantage? Of course, it's the lightweight. I discussed the low cost already. What else can you do? When you make something like this in the lab, it takes you like around, maybe if you originally think like a Tinker toy, like an erector set, you sit down and think, oh, I want to construct this. It's going to take you a while to make this. Let's say 10 minutes. Then you say, wow, I spent 10 minutes constructing this, and it doesn't cost that much, so I'm not gonna take this apart. So now this becomes my lamp housing. You can add a condenser, like I say. No. So next time you're making an autocollimator, and you have a lens tube here, and you say, oh, I don't want to disassemble this. I'll just put this out. Like I said, when you have something inexpensive, that's what happens. So what you end up doing later is you will take the already constructed lamp housing and the already constructed lens tube, and you put it together. So you now have modules. This is the biggest advantage to this system. So when you make a microscope, you can just put these things together now with parts with sub-assemblies, rather than having to construct everything with tiny screws. You know, if I just want to show you, let me put this back on the, if I could find the screw here. These are tiny screws. Oh, there we go. I always see a technician bending down, picking up. I mean, small parts are really difficult to work with. In any case, I need a tweezer to assemble this. This is so tiny. These parts are, it's like a watchmaking. Here you go. Really micromechanics. What we have achieved here is really, here you go. So, like I said, you don't have to keep doing this with Optoform anymore, because you can, by the way, I want to show you some new clever ideas in here that are the result of playing. We are the original idea, this idea came out with us. I know Torlab already copied us. But anyway, we have this newsletter I will tell you about. This mount along the plate, so you can mount in any direction you want. We have another mount that slides along the plate. So we have, let me see if I have something to show you here. Here you go. This mount is able to move in between the plates, you know, slide along. So there we have it. I just want to show you about the what culture we bring with our products. It's really something unique, and you will find that in our publication. This is a quarterly publication called Optomechanics. We go to trade shows, we show different ideas here, but it has pages that discussing new ways to construct Optoform. Here's a microscope constructed with Optoform, and you know, coherent illumination you can easily achieve. If you're a department, like a software department at the university, robotics, etc., like biology department, you want to sort DNA, chromosomes. The input to your software would be optical, you see. And with this new system, you can construct a microscope easily, put a CCD, and you know, with the tablet right now everything is wireless, and you can construct this system. So we're going to have, I hope, depending on how successful we are in our advertising and how to we show this at many trade shows as possible. Because like I said, we are not a marketing powerhouse that has all these funding, you know, to promote this product, but it's extremely beneficial, because You can, if you have these mounts laying around your lab next to your PC board, LCD panel, whatever, you can construct anything you like with it. We have construction components like really an erector set. And our concept of an erector set is you cannot call it an erector set unless you can play with it. A child can play with it. In any case, if you are those departments at a university, the input to your software is really good optics and good mechanics. And I think Optoform can help you to achieve that. And really our success is going to be the satisfaction of our customers. Thank you very much.